Welcome to Play with the Universe. Today, I play with the sun by throwing some astronomical objects at it. And of course, nothing less than the speed of light. But first, I need to adjust the speed of the simulation. 1 second in the simulation for 1 second in real life. Now, it's time to choose the first astronomical object to throw. Let's go with a planet, and nothing less than the largest in our solar system, Jupiter, with a diameter of about 88,695 miles, or 142,800 kilometers. Which represents more than 11 times the diameter of Earth. Jupiter is locked on its target, the Sun. That means it's time to play. But before the launch, I just need to change the speed of this gas giant. And as I told you at the beginning of the video, nothing less than the speed of light. 792.5 kilometers per second. Now we are ready. As you can see, this is the speed of light. For this first astronomical object, I will not increase the speed of the simulation. For what? Because you have to see how slow this speed is in the universe. In the Star Wars saga, the speed of light seems faster. It appears that ships travel from one solar system to another in a short time. But as you know, it's science fiction. In reality, the distances covered by the Millennium Falcon would take years to achieve. In comparison, the closest star to our solar system, Proxima Centauri, is about 4.2 light-years away. Here, to start its journey, I have placed Jupiter close to the orbit of Mercury, which is located approximately 58 million kilometers from the Sun. We are moments away from the fateful moment. And remember, it's a simulation. Wow! I need to increase the speed to see what that blue dot is. As we can see, the collision of the two astronomical objects caused a gigantic explosion, leaving only fragments to propagate at high speed. For the next collisions on the Sun, everything will go faster, since now we know what the speed of light looks like, and the projectile will be Saturn. I adjust the speed. Okay, already sent to the Sun, and it turned blue. Look at the temperature, over 600,000 degrees. The trail behind shows that the Sun was pushed by Saturn, and the planets are abandoned there. For the third simulation, I will use Neptune as a projectile. Boom! The result of the impact is very similar to that of Saturn. The blue color of the Sun, the temperature, which is gargantuanly higher than normal, and the Sun is moving away from the planets, with an Earth that still clings to its star. Surviving wouldn't be easy with temperatures and an orbit that are far from stable. For this fourth simulation, I will go directly to the launch of the last planet, Pluto. I know what you're thinking. Pluto is not a planet. Well, here's my answer.
Of course Pluto's a planet, son. I learned that in the 3rd grade.
Well, yeah, but, they changed it.
Morty, nobody changed the planet.
Pluto's not a planet. They changed it in 2006.
Yeah, I heard about that, Morty. And I disagree.
You disagree?
That's right. It's possible to disagree in science, Morty. Pluto was a planet. Some committee of fancy assholes disagree. I disagree back.
Whip! Jerry is my man. Okay, time to launch. Interesting. The planet, Pluto, created a kind of tsunami of hellfire. The temperature has also risen very high. Okay, now I've reached the last astronomical object to test. Not a star. Not a planet. Neither a moon. Nor any other astronomical object. But maybe I will find something interesting here. Pigeon. A space pigeon. I'll name her Bertha. But I must not get too attached to this animal. Okay, time to launch. Meh. Absolutely nothing happened. I am so disappointed. So, the video ends like this. Get out of here.